Coulomb counting is a fundamental technique used in battery management systems to estimate the state of charge of a battery. But what exactly is it? And how does it work? At its core, Coulomb counting relies on the principle of conservation of charge, which states that charge can neither be created nor destroyed, only transferred. When a battery charges or discharges, electrons flow in or out, respectively. And by measuring the amount of charge transferred, we can estimate the battery's state of charge. But how do we measure this charge accurately? That's where Coulomb counting algorithms come into play. There are several approaches, but one common method involves integrating the current flowing in or out of the battery over time. Z is the charge accumulated in the battery cell at different time steps. K is the current step and K plus 1 is next step while calculation. Delta T is the time interval selected in which current is assumed to be constant. The eta is Coulombic efficiency of battery. Generally it is assumed 1 and it is estimated from laboratory experiments. This the input or output current from the battery and it is constant in the considered time interval. This is Q and its value taken from manufacturer datasheet named as cell or battery nominal capacity. The value of Z at time step K is initial state of charge. When the system is at rest, the battery voltage is open circuit voltage. Measure the battery voltage using voltage sensor and use this value to get initial state of charge. From this voltage versus state of charge curve, this curve is prepared at laboratory. Calculate this value by taking small time interval, nominal capacity, and Coulombic efficiency is 1. For different time intervals you need to calculate this whole value at each time step. Now take current measurement from current sensor. Now multiply previously calculated value and current. There is no unit of this value because unit of Q is ampere hour and multiplication of time interval with current is also ampere hour. Here direction of current is important. While charging current is assumed to be negative and while discharging current is assumed to be positive. Using this formula you can calculate the battery state of charge very easily. While calculating the state of charge, you will accumulate the error as shown in figure. After every few iteration you need to correct this algorithm. There are other advanced methods to calculate the state of charge which is Kalman filtering, electrochemical modeling approach, data-driven methods like machine learning, neural networks, etc.